Okay, I'm gonna finish the flexure portion of the slab example by picking out the steel. And I did this ahead of time, so I could just do this for you. And so here we go. We need at A, 0.14 inches squared per foot. At B, 0.171, just over 17 inches squared per foot. And at C, 269 inches squared per foot. And what I have here is a table that lists inches squared per foot for various bars spaced at different spacings on center. I've decided I'm going to use number 4 bars in the slab. And so looking for the green one, 0.14, that can be achieved by putting the number 4, 17 inches on center. To get in the midspan, 0.171 square inches per foot. I guess you could do the 14 inches, but 13 inches on center. And to get the orange at at C, you would need 9 inches on center. Now, typically, I would move that 17 inches on center up to something easier, 16, and that 13 inches on center to 12. But my wife's birthday is on the 13th. And so I'm gonna keep it at 13 inches on center in homage to her. And so while I'm doing that, I'm keeping the 17 inches on center. Although realistically, I probably would do the blue at 12 inches on center and the green at 16 inches on center. And so here's the final sketch. Again, I'm color-coded orange, blue, and green right here. But I want to do something a little more interesting that I saw in the Dolan book, and I got slightly different numbers. So let's try this. I'm going to go ahead and bump this middle bar to number 4 is at 12 inches on center, getting 0.2 square inches per foot right here. Okay. And at A, this left support, we need 0.14 square inches per foot. And so I'm trying to figure out what ratio of the number 4, 12 inches on center, I need to bend up to get 0.14. So I took what I need, 0.4, divided it by what I have in the midspan, 0.2, and I come out with 0.7. And so if the closest ratio fraction to that is 3/4. You could bend up 2 out of every 3, 3 out of every quarter, half of them. So if you bend up 3 out of every 4 bars, you get 75% of 0.2 inches squared per foot. And so you get 0.15 inches squared per foot, which is greater than the required 0.14 inches squared per foot. So in here, so out of these 4, out of those 4, if you bend up 3 out of 4, you will get 0.15 square inches per foot on that side. Now, remember that there's 2 spans. And so if you bend up 3/4 of the bars in both spans up here at C, you'll get 0.15 square inches per foot from both sides for a total of 0.3 square inches a foot, which is greater than the required 0.27 square inches per foot. So what you can do is, so for every 4 bars, if you bend up 3 to A and 3 to C, you will get, on the left side, you'll get 0.15 square inches per foot. And on the right side, you'll get 0.3 square inches per foot because you're bending up 6 bars, right? Because there's 3 bars on the left, 3 bars on the right, and 6 bars will get bent up there for every 4 on both sides. And that's what I've shown in this drawing down here. And I didn't want to draw it, but what you ought to do is stagger how you bend them up on the left and right spans. Let's see if I can draw that. So let me copy that, paste it here, paste it here, and this is what you want to do. Okay, so this is the left span and the right span. I've only drawn the left span above, but you want to stagger it like this, how you bend the bars up and which ones you don't, something like that. Okay. Anyway, as long as the bars average out to the right amount, it'll work out. And so here you can see this bar right here, the ones that aren't bent up, they're every 4 feet on center because they're every 4 bars and they're at 12 inches. And you can specify in the drawing, put these at 16 inches on center, or just try to explain it like this, like put all the bars every 12 inches and every 3 out of 4 are bars that are bent up. So the bars that bend up are 3/4 of the bars, and the bars that aren't bent up are 1/4 of the bars. And where we cut them off and where we bend them down, we haven't talked about how to do that, so I've not mentioned that. We'll talk about that later. But anyway, this is the final solution to the flexure part of this problem. I'll circle back to this problem after we talk about shear strength, and we'll do a quick shear check, and you will find out that the shear is no problem. So there you go. If you buy the Dolan concrete book, there's a little bit different choice of bars, but the concept's the same. That's where I got the idea of bending some up, keeping some straight. It's a very interesting discussion there about how to do something like this. Okay, so that concludes the slab example. Next, I'll make one last example for the whole flexure section where we design a slab and T-beam combination. And let me make up a problem for that, and I'll post that video in a little bit.